All right, let's look at another example where we want to find the inverse of a domain-restricted function. This will be problem number 5 on your test. So f of x equals x squared minus 4 over 2x squared, where we've restricted the domain to be x is greater than 0, okay? Now, normally, if you look at f of x, let's say f of x is equal to x squared minus 4 over 2x squared. If I don't specifically say x is greater than 0 here, well, in this case, your domain is a set of all x such that x is not 0. Okay, that's your only restriction because you have an x squared in the denominator. If you plugged in a 0 there, 0 squared is 0, 0 times 2 is 0, you can't divide by 0. Okay, if you look at the graph of this guy, you would see that it's not defined where x is 0, and also this guy is not 1 to 1, right? If you draw a horizontal line, the graph is going to be impacted in more than one location. So to fix this problem, to make this guy 1 to 1, we're restricting the domain. So we're going to take a piece of the graph. So anywhere where the x values are greater than 0, okay? So we'll have a restricted domain, but the same range. So this guy right here is what we're going to be working with. You can write this out again as just f of x is equal to your x squared minus 4 over your 2x squared, where x is greater than 0. Okay, so we're just taking a piece of the graph. Now let's go back up. And let's erase this. We know why we need a domain restriction. Let's think about this. Okay, so the first thing I want to do if I'm finding the inverse is replace f of x with y. So y is equal to x squared minus 4 over your 2x squared. And I'm specifically here going to say that x is greater than 0. Okay, so from here, what I want to do is I want to swap my x's and my y's, okay? So in other words, I have a y here, this will become an x. I have an x here, this will become a y. And I have an x here, that'll become a y. Okay, so this is x, and I meant to use a marker there. So this is x is equal to, we'll say y squared minus 4 over 2y squared. And now because I had x here is greater than 0, I swapped the x's and the y's around. So the domain is going to become the range. So this will be y is greater than 0. Now, on some problems, you'll see me list the range, okay? In this case, it's a little bit harder to find. So what we're going to do is we're going to find the domain, the x values here that are allowed for this guy, this inverse, and that's going to give us the range from the original. We're not asked for it, but I'll just show you what it is, okay? So let's come down here, and let's go ahead and solve this guy for y now, okay? And then we can replace that with f inverse of x. So I'm going to multiply this by 2y squared, so I can clear that denominator. To make it legal, I'm going to do it over here as well. And so this is going to cancel, and you'll have your 2, I'll put xy squared like this, is equal to, I'll have y squared minus 4, and then where y is greater than 0. Okay, so if I want to solve this for y, I've got to get all the terms with y involved on one side. So y squared and y squared. So that means I need to what? Subtract y squared away from each side of the equation because I'm trying to basically move this over here, okay? So what's going to happen is this is going to cancel out. That's gone. Over here, I basically have 2xy squared, now minus y squared, okay, so everything's on the same side, and this equals my negative 4, where, again, y is greater than 0. Okay, let's come down here a little bit more. Now, you might be thinking, how in the world are we going to solve for y? I have y squared here, I have y squared here, and again, I have this subtraction sign here, so what you should be thinking here is factoring, right? You can pull this guy out, okay, and put it in front of a set of parentheses. So I can say y squared outside of a set of parentheses, okay, and then I'll have 2x minus 1, and this equals my negative 4, okay? Again, y is greater than 0. Let me copy this. I'm going to run out of room on the sheet. And what I want to do, since I have this y squared, I'm trying to get y by itself. Right now I have y squared. I've got to do this one step at a time. This is multiplied by this quantity 2x minus 1. So to undo that, I'm going to divide by 2x minus 1 on both sides. Okay, so nothing illegal. And we'll go ahead and cancel this out. So that's gone. And basically I have y squared is equal to, I'm going to have negative 4 over my 2x minus 1, and then y is greater than 0. Now, before we run into any issues, I've already solved this problem, so I'm just going to tell you in advance, when you go to take the square root, if you think about the square root of negative 4, that's going to not be a real number. Okay, so we don't want to run into any issues. So to fix this, because this is a fraction, I can legally multiply this by negative 1 over negative 1 and just change the form. Okay, so instead of negative 4 here, this will be positive 4, and this would be negative 2x, and this would be positive 1. So it's the same thing. It's the same value. I'm just changing the way it looks. Okay, so I'm going to rewrite this actually as 1 minus 2x. So 1 minus 2x like this. Okay, so now all I really need to do, scroll down a little bit, to get y by itself is take the square root of each side. I'm going to go plus or minus over here. You're not going to need that minus, and I'll show you why in a moment. But for right now, let's just write it in for the sake of completeness. So this is going to cancel with this. I'll have y is equal to, I'll go plus or minus, let's go square root of 4 over your square root of 1 minus 2x. Okay, and let me copy that y is greater than 0 because we're going to need this right now. Okay, so let's think about this. Plus or minus the square root of 4 is plus or minus 2. Okay, all right, so the reason you can throw the negative out, basically think about the fact that the result of this needs to be greater than 0, right? We're going to be in the denominator, so we can't be 0, so we need to be something greater than 0. Okay, if I have positive 2 over a positive, that gives me a positive, so y is greater than 0 is going to hold. Okay, if this was negative 2 divided by a positive, I would then get a negative, and so y is greater than 0 would not hold, so you can throw out the negative. Okay, so you can get rid of that. Additionally, if you want to think about this now, if you want to know the domain, so x is what? Well, if we think about this square root operation, again, we always take what's inside. We say 1 minus 2x, and we say is greater than or equal to 0. Because this is in the denominator, I'm going to now say it's greater than 0. Okay, strictly greater than, because we don't want a 0 there. Okay, so I'm going to subtract 1 away from each side, and basically I'm going to have negative 2x is greater than negative 1. Divide both sides by negative 2. Remember to flip the direction of the inequality symbol. So this is going to give me that x is less than 1/2. Okay, so you can actually use that. You can use that. Let me put this x is less than 1/2. If you wanted to go back and put the range of that original domain restricted function we're working with, it's that x is less than 1/2. If you revisit the graph, you're going to see when you look at this guy that your range here was that y is less than 1/2. So that became your domain when we found the inverse. Okay, so let's go back, and we have our inverse, but we just want to clean it up a little bit. I'm going to replace y with f inverse of x, so we have the right notation. And then I'm going to rationalize the denominator here. So I'm going to have 2 multiplied by the square root of 1 minus 2x. And this is over 1 minus 2x. So all I did was, let me scooch this out of the way. I just multiplied this by the square root of 1 minus 2x over the square root of 1 minus 2x. So I could rationalize the denominator. So y is greater than 0 and x is less than 1/2. Okay. So if we look at this now, the x is less than 1/2 still holds because you have this domain restriction here, okay? And basically that's going to get you to where x is going to be less than or equal to 1/2, and then it can't actually be 1/2 because if you plugged in 1/2 there, the denominator would be 0. So it's the same thing, okay? So basically here I'm just going to list that x is less than 1/2, okay? So this is your inverse function. Let's go back. We look at these guys on a graph together. Again, this is your f inverse of x, which is your 2 times the square root of 1 minus 2x over 1 minus 2x. Again, x is going to be less than 1/2. Okay, but basically this is the inverse of this guy, which is your f of x is equal to x squared minus 4 over your 2x squared, where x is greater than 0. Okay, and you can see this is the line, again, y equals x. I always do this for comparison. And you could take a point like, let's say 2, 0, reflect it across this line, and you're going to get 0,